Hello all. In my previous videos, I have talked about Hazop, what Hazop is, how to conduct a Hazop with a practical example. If you have not watched that video, please see in the description. There is a link available to see all these videos. In this particular video, we will be basically talking about different parameters and guide words that are commonly used in the Hazop. This will provide you a basis while you are doing the Hazop. So let's go through it. So as we all know, the parameters in the Hazops are different process parameter. For example, flow, pressure, level, composition, etc. Now flow is one of the process parameter, and what will be the guide words? So guide word can be no or less. So when you combine the parameter with the guide word, it's become low or less flow. Again, another parameter is more. So when you combine the more with the parameter, it becomes more flow. Similarly, reverse flow, misdirected flow, as well as flow elsewhere. This is the meaning when you have, suppose there is some uh, there is a node when the flow is coming from two direction and there is a three-way valve here, right? So flow may come from this side, flow may come from this side. So this is used in that case. Then part of means there can be a wrong concentration. So suppose you are expecting around 10% of amine in the solution, in the aqueous solution, but it increases to 30%. So that is a wrong concentration. So flow, everything is same. There is flow is normal, there is no reverse flow, there is no misdirected flow, but the concentration of the flow is different, right? Same thing may happen is when there is a combination of phase. There is a vapor phase along with the liquid phase, or there may be a contamination. So the liquid may contain some solid particle, right? So then it becomes a chance of contamination. So I would say that more commonly used guide words are these two, or the first three you can say, and these guide words are rarely used, but it is good to have this also in your mind so that you do not miss any process situation that may lead to hazard, right? Similarly, for the pressure, it can be high pressure, it can be low pressure, or it can be no pressure. So no pressure means the vacuum situation. Okay. Temperature is also straightforward, high and low, high temperature, low temperature. Level also high, low. Composition means the whatever component content in the fluid. So there can be no agitation, there can be less agitation, there can be more agitation, there can be wrong concentration also. Similarly, there are some other situation which can be the situation like shutdown, startup. So what happens in the process, like sometimes the situation in the shutdown is totally different, or in the startup case the logic, the fluid, the pressure, temperature, everything becomes different. So there may be a startup condition, there may be a situation of maintenance. Power failure, this is very important thing when you are doing Hazop for the whole complex. So how the power failure will impact your process, right? And then steam failure. So there are for the power failure, so this basically gives you the risk of power failure, and from here people basically determines the load shedding schemes, how to shed your loads, right? So suppose you have two gas turbine, one is 25 megawatt, another is another one is also 25 megawatt, and one of them suddenly got tripped or there are some issues. So now you have only 25 megawatt available. So within this 25 megawatts, which all pumps you want to run, which all compressor you want to run? You want to run this critical things which may not pose you a safety hazard or something. So for that you need to have a load shedding key. Similar case situation is for the steam failure. So CW failure is a cooling water failure, IA failure is a instrument air failure. Then there can be inert gas failure, which can be a case like if your tank is with nitrogen blanketing, right? So nitrogen is a inert gas. So the nitrogen blanketing actually covers the whole tank with a safety layer, right? Now suppose that nitrogen gas, somehow that nitrogen valve got stopped or got closed, or the nitrogen production facility got tripped or something, that will result in inert gas failure. So if that inert gas failure happens, what happens to your tank? Then there can be situation of spill, leak, catalyst change, wrong material charged, effluent capability, sampling isolation, equipment failure, static electricity, location, area of classification, piping, approach, legal, temporary. So this all these other guide words, they are not very like frequently used, but there are situations where you need to use these guide words to know all the hazards and risk that you are exposed to, right? But some of these are very critical. For example, the power failure, steam failure, cooling water failure, instrument air failure. So this you need to keep in mind always, because there are situations that happens where your instrument air can get failed, and in that case you cannot move the valve to the predetermined state, right, where you want to move. So your valve should be designed in such a way that in case of the instrument air failure, the valve goes into the safe state, not into the unsafe state, right? So for example, suppose you have a vessel or something, and out of this there is a control valve, and that is connected to flare, right? This is connected to flare. Now in case of the instrument air failure, this valve should open so that the material should can go to the flare, right? But if it happens otherwise, that instrument air failure, this valve does not open, then there is a risk. And how you will mitigate the risk? Okay, so that's why these guide words are very important. So hope you have understood the different guide words and how to use them. Thank you.